Welcome to today's tutorial. So in this tutorial we are going to discuss what parallel vectors are, and we are also going to solve some questions concerning parallel vectors. Alright, so if you have not yet subscribed to the channel, make sure that you click on the subscription button so that you don't miss out the videos that I'm going to be posting. And don't forget to click the notification button so that you don't miss every time I post a question. If you have any questions, feel free to contact me using these lines on the screen. Okay. Alright, so this is the question here. The question says determine which of the vectors is or are parallel to Z. So in the first case there, Z has been given. Z has been given there. But before I start solving this, let me explain what parallel vectors are. So parallel vectors, or let me say two vectors, are said to be parallel if they are a scalar multiple of each other. Meaning if Z is parallel to U. Okay, let me just say if Z is parallel to U, if the vector Z is parallel to the vector U, this means that Z is equal to KU. So this U you can use C, you can use U, you can use any variable that is normally used as a constant. So you can use K or C, there's no problem. Or you can use any Greek symbol there, there's no problem. So Z is equal to KU. Some books will say Z is equal to CU. This implies that these two vectors are parallel. Or you can say U is equal to KZ. It's still the same. Or U is equal to CZ. It's still the same. Alright, so if two vectors are parallel, they are a scalar multiple of each other. And then let's quickly begin to look at the practical examples. So the first example that we have, Z has been given as 3, 2, -5. And then U here has been given to be, so U has been given as U has been given to be 1, -4, 2. So remember what I said, if two vectors are parallel, so we can write these also in this format, which is okay, let me first write the equation. So if Z is parallel to U, then Z is going to be equal to K U. And we can write these vectors in this equation. So we have 3, 2, -5. So this is equal to K 1, -4, and 2. So we can try to find the values of K on at least two components or two terms in these vectors. So if I take the first line there, I'm going to get 3. I'll say 3 is equal to K times 1. So K times 1, that will be K. So in the first case, the value of K is equal to 3. In the second case there, I'm going to have 2 being equal to K times -4. So if I divide by -4 on both sides, the value of K becomes -1/2. To be -1/2. So looking at these two values of K, since they are different, this tells us to say the given vectors are not parallel. So we were supposed to find these two values of K are supposed to be the same. even on the last part here, if you try -5 is equal to k2, you find that the value of k is equal to -5/2, which is not equal to these other values of k. So the three values of k are supposed to be the same for these two vectors to be equal, or rather for these two vectors to be parallel. Alright, so let's quickly move on to the next one. So the next one we have v. Oh, sorry, we are comparing z to u, v, and w. So we get v. So we're saying z is equal to k v. So z has been given as 3 to -5. And we have k there. And then v has been given as -6, -4, and 10. So when you get the first part there, we have 3 is equal to k -6. So when you divide by -6 on both sides, we're getting, so we divide by -6, the value of k is equal to -1/2. Move on to the next case there. So we have 2 is equal to k -4. Then when you divide everything by -4, the value of k becomes -1/2. We move on to the third part. So the third part is -5 being equal to k times 10. So when we divide by 10, the value of k is 1/2. -1/2. So the first k is equal to the second k. It's also equal to the third k, which implies that the given vector z is parallel to v. So z is parallel to v because we know to say z is equal to -1/2 v. So these two vectors are parallel because we have found the values of k to be the same. We move on to w then. So we write, so we are going to write w following the same procedure. So we say z is equal to kw. And we put in the figures. We have 3 to -5 and equal to k times w. There is 2, 4/3 and -10/3. So let us see if these two vectors are parallel. So we get the first case there. We have 3 is equal to k2. So when we divide by 2 on both sides, we find the value of k as 3/2. We move on to the second part there. So the second part, we get 2 this side, and we also get k there times 4/3. When we divide everything by 4/3, we get the value of k as, so we're dividing this by 4/3 and dividing this part by 4/3. So we're getting this as this as 3/2. We move on to the last part there. So the last part is -5 is equal to k -10/3. So divide everything by -10/3, divide everything by -10/3, and the value of k is so this will be 3/2. So since the value of k there and there, even there, are the same, the values of k are the same, we conclude that z is parallel to w because z is equal to 3/2 w. So the same way I have solved the first line there, the first one, which is I, is the same way you solve the second lines, except that the second part has been given in Cartesian form. Okay, let me solve 1 or 2 and then you get the remaining ones as an exercise. Alright, so the first one there we have, so we have to get the same values of z, the same formula. Z is equal to k, ku. So z here is 1/2, we have -2/3, then we have 3/4. And you are saying this is equal to k, open brackets. The value of u there we have 6, negative 4, and 9. So we first find the first value of k. So we're going to get half there. We say this is equal to k times 6. So when we divide everything by 6, we're getting k as 1 over 12. We move on to the second value of k. So I'm going to get negative 2 over 3 this side, and this other side we have k, negative 4. Divide everything by negative 4. If you divide everything by negative 4, we're getting the value of k as 1 over 6. Yeah, that will be 1 over 6. So since the first value of k is different from the second value of k, we can conclude that the vector z is not equal to is not parallel to the vector u. All right, we move on to the second part of the question. So second part, we also do the same. In this case, we're comparing it to v. We're trying to check if it's parallel to v. Okay, so we put in z. We have 1 over 2, we have negative 2 over 3, we have 3 over 4. So this is equal to k. We have negative 1, we have 4 over 3, we have negative 3 over 2. So we get 1 over 2 this side, and we say this is equal to k, negative 1. So when we divide by negative 1 on both sides, we're saying k is equal to negative half. This is the first value of k. We find the second value of k. So negative 2 over 3 is equal to k, 4 over 3. So when we divide by 4 over 3, we are getting the value of k as, remember, if we this and that will cancel, but this side we're going to have something like this, divided by 4 over 3. So to divide this, we are going to change the sign in between. This will be 3 over 4. So this and that will cancel. So we remain with 1 over 2, negative 1 over 2. So this is the second value of k. We find the third value of k. We compare the first one there, which is 3 over 4, is equal to the last one rather, which is equal to k, negative 3 over 2. Divide by negative 3 over 2, divide by negative 3 over 2. The value of k is equal to negative 1 over 2 as well. So since this first value, the second value, and the third value of k are the same, we can conclude that z is parallel to v, because z is equal to negative half v. This is exactly what you're supposed to do when you're solving these questions. So I want you to solve the last part of the question and send the solution to any of these lines on the screen, on WhatsApp, on Facebook, on Telegram. And let's see how you're going to do it, if you're going to get it correct or wrong. So see you in the next tutorial video. My name is harmtedy. Don't forget to subscribe to the channel. See you. If you have any questions, feel free to contact me using these lines on the screen. Shalom, shalom.